All right, welcome to This Explainer. Today, we are quite literally jumping into the cockpit for a high-altitude, high-stakes mission. We are tackling what is notoriously one of the absolute toughest, most unforgiving topics in the entire Cambridge IGCSE 0625 physics syllabus. I'm talking about Momentum 2. Now, think of today's exam strategy session as your ultimate comprehensive flight manual. We're going to break down exactly how momentum appears in real systems, how it behaves in complex calculations, and most crucially, how it actually shows up to trick you in those advanced exam questions. If you have ever felt completely lost in the physics danger zone, struggling to connect those abstract equations to actual tangible physical effects, then you need to strap in right now. We are going to completely transform the way you approach these high-pressure exam scenarios by locking on to a pure, application-first strategy that examiners absolutely love. Let's get right into it. Okay, I want you to imagine you're sitting in the exam hall. The timer is ticking. You're staring down a massive, intimidating momentum question. Let's look at two very common, frankly dangerous profiles that pop up on the examiner's radar every single year. First up, we have Alex. Now, Alex is smart. Alex overloads on raw physics facts and memorizes the formula with perfect recall. But here's the fatal flaw. Alex just slaps that formula onto the page without analyzing or explaining what any of those variables actually represent in the physical world. It's just raw data with zero context. Then, on the other side, there's Sam. Sam gets nervous, rushes the answer, totally misses the strict command word requirements, and describes a process but completely fails to link it to a tangible physical effect. Both of these students are flying entirely blind. They're falling into classic, avoidable traps, literally bleeding marks on the page, simply because they aren't demonstrating to the examiner that they actually understand the real-world physics behind the symbols. So, how do we navigate around these massive exam traps? We need a bulletproof tactical maneuver. As our source material directly points out, the absolute safest, most reliable method to structure your advanced physics answers is a rigid four-part sequence. Listen closely to this. Definition, relationship, explanation, application. This isn't just some helpful suggestion I'm throwing at you. This is a proven, strictly examiner-approved framework. It completely forces you out of that dangerous habit of rote memorization and pushes you to actually demonstrate true, high-level scientific reasoning. If you can master this exact sequence, I promise you, you will instantly stop losing those easy, frustrating marks that keep you from the top grade boundary. So, the absolutely crucial point here is how we actually execute this under pressure. Let's break down our four-step flight plan. Step 1, you clearly identify the quantity or the core phenomenon. Step 2, you explicitly state the relationship involved. Step 3, you explain the underlying physics of what's happening. And Step 4, you securely connect it to an observation, an experiment, or a real-world device. You must follow this flight plan precisely in that exact order. Why? Because the very best Cambridge physics answers don't just show that you know an isolated fact, they show a seamless, logical blend of deep understanding and practical application. Skipping a step here is literally like skipping a pre-flight check and inevitably leads to a crash in your final grading. Now, before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit that bell icon right now. Awesome. Let's keep moving. Let's zoom in on the core philosophy that makes this entire system work so flawlessly, the application-first understanding. Before we even think about throwing symbolic relationships, complex math, or formal physics vocabulary onto our exam paper, we need to stop, take a breath, and define the core idea. The very first question you should always ask yourself is, what physical effect, what measurement, or what prediction actually depends on understanding this momentum 2 interaction? By forcing yourself to grasp the physical reality first, you make the mathematical concept feel necessary, rather than just some decorative formula you memorized. This shift is a total game changer. It makes you infinitely less dependent on memorized textbook wording when a completely weird or unfamiliar exam question suddenly comes your way. And this timeline brilliantly illustrates exactly how top-tier students naturally progress their reasoning during an exam. Notice the incredibly smooth transition here. You don't start with the hardest math. That's a rookie mistake. You start at step 1, identifying a simple, concrete, everyday example. Once you have that anchor in reality, step 2 is introducing the precise symbolic relationship, and you only do that when you're actually ready for it. Step 3 is then formulating a detailed worked explanation based directly on that relationship. And finally, step 4 is the high-level analysis, asking what the slope, the area, the direction, or the shape of a given graph means physically. It's a calculated step-by-step transition from simple, everyday language straight up into precise grade A physics vocabulary. Let's move on and see how this builds into what we call a pure cause and effect chain. Whether the momentum interaction we're looking at involves magnetic fields, applied forces, or colliding particles, examiners absolutely unequivocally insist on seeing a clear, unbroken sequence in your writing. Look at the flow right here. A field or a force initiates the event. Then, the particle or the system interacts. Next, a clear physical change occurs. And finally, an effect is confidently predicted. You see how that flows? Examiners will severely penalize students who just randomly list isolated facts in a bulleted format. You have to tell the full story of the physics. You have to show them the dominoes falling in perfect order: cause, interaction, change, effect. That is how you dominate these questions. Now, what's incredibly powerful about what we're looking at right now is our examiner's radar. We directly mapped the exact specific flaws that are losing you marks to the precise tactical fixes that will guarantee your success. Listen to this. If your weakness is just slamming down the correct formula and hoping for the best, your tactical fix is to explicitly write out and explain what every single variable represents. If you catch yourself vaguely quoting a process, your instant fix is to link that process directly, without hesitation, to a physical effect. And if you drop a real-life example into your paragraph, you absolutely must show exactly why that example follows from the core physics. It is all about keeping every single microtopic tightly undeniably connected to both your classroom reasoning and the rigid exam structure. To master the absolute final step of our flight plan, which is application, you must lock your sights onto at least one of these real-life targets. Momentum 2 isn't just boring classroom theory, okay? It literally governs transport safety crash tests, massive engineering and construction projects, complex energy systems, communications networks, cutting-edge medical technology, and even astronomy and space exploration. A Cambridge examiner fully expects you to be able to confidently name at least one real situation where the concept deeply matters. But listen to me, don't just name drop it. You have to justify the link. You have to explain exactly how understanding the physics of momentum helps us predict or improve the outcome of that specific real-world system. Now, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are officially on our final approach. It is time to initiate the ultimate pre-flight checklist. The source material provides 4 rapid-fire, high-pressure memory prompts. Think of this as your interactive workshop. These prompts are your absolute ultimate test. If you can answer these 4 prompts aloud without hesitating for any Momentum 2 topic they throw at you, you can be 100% confident that your knowledge is fully battle-ready for both short answer and those massive, structured questions. Let's go through them right now, one by one. First up on the checklist, what is the core idea? Now, I want you to think really hard about this. Before you write down a single equation, before you quote a single rule or principle, can you clearly define the absolute foundational principle of the system? You need to be able to state the key idea out loud in plain, everyday language, establishing exactly what fundamental physics principle is at play in the scenario, completely without leaning on a mathematical formula as a crutch. If you can't say it simply, you don't know it well enough yet. Second prompt on the radar, what changes physically? Think back just a moment ago to our cause and effect chain. During this exact momentum interaction, what is physically, visibly altering? Is the velocity dropping? Is the mass combining? Is the direction totally reversing? You need to accurately and meticulously track the sequence of events. If you can't accurately describe the actual physical change happening in the system, let's be honest, you aren't really communicating physics at that point. You're just doing blind math. And the examiner will spot that instantly. Third on our crucial checklist, what quantity or graph actually shows it? This is exactly where your measurement skills come in. Can you explicitly point to the specific measurement, the exact calculation, or the practical use connected to the event? If they give you a complex data source or a graph, can you flawlessly explain what the slope, the shaded area under the curve, or the overall direction actually proves about the physical change that is happening in real time? Connecting that physical change directly, undeniably to the data on the page is absolutely vital for unlocking those top-tier marks. Finally, we hit the fourth and final prompt. Where is it used? This perfectly ties everything we've talked about directly back to the real world. You need to be ready to provide one highly specific, real-life example where this exact momentum 2 interaction actually matters. It could be the crumple zones in crash test dummies, the thrust mechanism in rocket propulsion, or the collision mechanics in sports. But remember, the ultimate fix from our examiner's radar earlier. You must clearly, logically justify the link between your chosen example and the underlying physics. No half answers. And with that, we've safely landed the plane. Let's look at this absolutely massive final takeaway. Physics isn't just some hurdle you have to jump over to pass an exam. It is literally the ultimate tool for predicting the outcomes of our entire physical world. Truly understanding momentum, too, is exactly what allows engineers to design safer cars, scientists to launch satellites into orbit, and humanity to comprehend the mechanics of the universe. So the absolute next time you look at a complex physical system in your exam paper, I want you to ask yourself a very simple question. Are you just robotically reciting isolated facts like Alex, or do you actually have the analytical tools to predict exactly what happens next? Because mastering momentum isn't just about acing a test, it's about holding the blueprint to the universe. Keep applying these high-level strategies and you'll be flying at maximum altitude in no time. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.